All right, we have a question here that says, find the length of the curve of the vector function r of t with the parameters for t being between -2 and 2. I'm going to go ahead and write out our equation for finding the length of a space curve, which is L equal to the integral from a to b of the magnitude of our vector function, dt. And this is actually a relatively simple problem containing only 3 steps to find the length of this curve. First, we're going to take the derivative of this function written as r prime of t. Then the second thing we're going to do is find the magnitude. And once we find those values, we're just going to plug them into our formula and integrate to find the length. Alright, so starting with step 1, we are just going to find the derivative of each part of our vector. 7t gives us 7. 3 cosine t gives us -3 sine t, and 3 sine t gives us 3 cosine t. And now we'll just use our magnitude formula and square each value, add them together, and take the square root. So we'll have 7 squared plus -3 sine t squared plus 3 cosine t squared. Alright, so now that we're squaring them, you might notice that we have a trig identity in here that we can utilize. So let's go ahead and group sine squared t and cosine squared t and bring the 9 out. Alright, so we're going to start grouping these. We're going to bring that 49 and that 9 down. And the trig identity of sine squared t plus cosine squared t is going to give us 1, so it's 49 plus 9 times 1, which will give us the square root of 58 as our magnitude. Alright, so now that we've found the magnitude of our vector function, we are ready to plug these values into our formula to find our final answer. So length is equal to the integral from -2 to 2 of the square root of 58 dt. And now I'll just rewrite this so we can integrate. And we've got the square root of 58 times t from -2 to 2. And we'll simplify this to the square root of 58 times 2 minus -2. And our final answer for the length of the curve is going to be 4 square root 58.